Hello everyone, Mittal Sakshi Mittal. I welcome you all to this second lecture on subject microprocessor KCS 403. In my second lecture, I am going to discuss about the 8085 microprocessor programming. So today we will discuss various concepts, how we can write a program to solve a simple problem to the complex problem, how we can use various instructions to implement any program using 8085. So see, let's take first problem. So we have to store the data byte 32H into a memory location 4000. So as we all know that this 32H, it is a 8-bit data. I have to store it in location 4000H. How can I store this number into the location 4000H? So 8085 supports various instructions, like I can load, if I want to load this number 32 into a direct location 4000, I cannot transfer immediate data to a memory address. So that is not possible in 8085. So how can I do it? So one thing can be that I can first transfer it to let's say a register accumulator. After transferring it to the accumulator, I can just transfer it to my memory. So this can be the step, that first you should load this number 32 into the accumulator, then transfer it to the memory location, which is 4000. So first, if I want to initialize this 32 number into accumulator, how can I do it? So for this, we have an instruction MVI. MVI says move immediate data. So you have to move. Immediate means the data which is present in the instruction. So 32H is the immediate data which I have to move into accumulator. So with the help of this instruction MVI A32, 32H is being loaded into accumulator, or we can say the register A. So now I have in my accumulator, this number is being loaded in accumulator. My next step should be to move it to the memory address. And where is the address? So address is 4000. So we have got an instruction STA, that is store the contents of accumulator. So I can directly write the instruction store the contents of accumulator, which is 32 into this address 4000H. So 32 is being loaded to the accumulator first, then we have moved it to the memory address. So in this way we are able to process this operation. And last should be halt, terminate the execution. Or we can have another way of writing this as well. I can first initialize the memory location LXI H4000. So this says load extended immediate value. So it says that you have got a 16-bit immediate number which is 4000. You have to load it into an extended register pair. So HL. So with the help of this instruction, HL register pair is being loaded with number 4000, where 00 move to register L and 40 move to register H. Next, I can write MVI. Again, I says MVI. So it says move immediate number. So you have to move immediate number, which is 32H, into this memory location. Now, where is memory location? So memory is always pointed by HL pair in 8085. HL pair is being designated as a memory pointer. So whenever I have any instruction related to the memory, the processor 8085 processor will go to HL pair. Whatever HL is having, it is being treated as a 16-bit address. It will go to that address. So now I am having 32 as an immediate data. It has to move to an address which is being stored in HL pair. So at this address 4000, this number 32H is being displayed. And my last instruction should be halt, terminate the program. Next, we can take example of exchange the contents of memory location 2000 and 4000. So I have got two addresses 2000 and 4000. We have got some numbers, let's say 2000 and 4000. So the question says you have to exchange the contents. For example, 17 is present at this location and 23 is present at location 4000H. So I have to exchange the content, both the contents. As we all are aware that 8085 is not capable of addressing two locations in the source and destination both simultaneously. Or I can say that memory to memory transfer is not possible in case of 8085. So if I have two locations, what can I do? I can first take this data. First you can take this data, maybe in a accumulator or any other register. Same way, store this, if this is in accumulator, store this number in any other register, maybe in register B. Now see, the data at location 2000, 4000, they are already preserved in two of my registers. They are now in very safe. So this contents of accumulator, I can now overwrite at this location 4000. So first data which was at 2000, it is being overwritten to location 4000. What I am left with, I have to move this content 23 to the location 2000. So whatever you are having in register B, now move it to accumulator and then again paste it to location 2000. So we'll see how we can do it with the help of instructions. So first is LDA 2000. LDA says load accumulator with the contents present at address 2000. So 2000 is the address which is having data 17, which is being moved to accumulator. My first task. Then I says move B comma A, that store this data into register B. So we have just make a copy of this data in register B. Then we says again load the data from 4000 into accumulator. So now accumulator is free because I have already have a copy. See, whenever I have any move operation, it is generally says that you have to copy and paste the data. It is never cut paste. So already the 17 is already stored in register B. So I can replace the contents of accumulator. So with this LDA 4000, this 23 is being stored in accumulator. Then STA 2000, it says store the contents of accumulator to this address. So what I am having in accumulator? Accumulator is actually having the data of location 4000, which we are saying you should display at this location. So the first data is being transferred. Now I have the data from location 2000. I have already stored it in register B. So just move it back to the accumulator so that you can just transfer it to the another address, which is 4000 with the help of instruction STA 4000. So STA 4000 says store the contents of accumulator to this address 4000. So whatever you are having in accumulator, that will be transferred to this address 4000. So now what you are having in accumulator, the data from location 2000, which was 17. So it will be transferred here. Last instruction, it should be halt, that is terminate the program. I can have another way of writing this program. I can first initialize the memory. So we'll have a look on the another example. LXI H 2000. So first I initialize HL pair with this address 2000, which is the first memory address. So LXI says load 16-bit immediate value. So 2000 is being transferred to HL pair. LXI D. So DE pair is being loaded with value 4000. So 00 being a lower 8-bit will move to register E and 40 will move to register D. Now I can say that move the contents of memory to register B. Now again, where is the memory? Where is the memory? So memory is again pointed by HL pair. So memory pointer is nothing but a HL pair. HL is having 2000. So the data which we have at location 2000, I assumed it to be 23, let's say 17. So it is being moved to register B. So the first data is in register B. Now next I write LDAXD. It says load accumulator with the contents, and X denotes extended. So that means D is not an 8-bit register, but it is being used as a DE register pair. So the contents of DE register pair, they are denoting you the address. The contents of that address you have to move to the accumulator. So DE is pointing to 4000 location where you have 23, which is being moved to accumulator. So now first we have loaded the data in two registers, that is A and B. Now I have to swap the contents. So I can write move M comma A, that is I have to copy the contents from accumulator to memory. What accumulator is having? Accumulator is having the data which was at location 4000. So just paste it at location 2000. Next is transfer the data from B to A. So again I am having the data back to the accumulator from register B to accumulator. And next you can write stacks D. This stack says store the contents of accumulator to this extended register pair. So DE pair is pointing 4000. Here the contents, that is 17H, which was stored in register B, and we moved it to accumulator. It is being displayed here. So in this manner you can exchange the contents, as we don't have a direct swap instruction available for two memory locations. And last instruction should be halt, terminate the program. Next is find 2's complement of the number stored at memory location 4200H and store the complemented number at location 4300H. So you have to find the 2's complement of a number. Whenever we say about the 2's complement, we know 2's complement is nothing but it is the 1's complement plus 1. So for 2's complement, you need a 1's complement. Once you have a 1's complement, just plus 1 to it to get the 2's complement. So how can we write it? So first is LDA 4200. As the question says that the input is present at location 4200H. So load accumulator with the contents present at 4200, which whatever your input is, it is being loaded to accumulator. Then you have to take the 1's complement. 1's complement says that you have to invert the bits. So for that we have got an instruction CMA, complement each bit of accumulator. For example, if you have here, let's say in accumulator you are having 55, which becomes 0, 1, 0, 1, 0, 1, 0, 1. So after CMA, all the bits will be inverted. It becomes 1, 0, 1, 0, 1, 0, 1, 0. So after CMA in accumulator, I am having the number as AAH. All bits will be inverted. Now 1's complement we have already taken, so I have to add 1. So I can write ADI 01 because I know ADI says that you have to add the immediate number. Immediate number is 01. You are adding it to which register? So this add instruction, it by default acts on accumulator. So the contents of accumulator will be added by a 1 and you will get the result back in accumulator. In this way you got the 2's complement, and now you have to display the result. So just write simply STA, store the contents of accumulator to this address 4300H. Last halt, terminate the execution. Next is add the contents of memory location 4000 and 4001 and place the result in 4002. So you have got two inputs, two 8-bit inputs, you have to add the numbers and you can directly place the result in 4002. So it's very simple. First, take the number, load the data from address 4000 and 4001. Obviously, you should have the one of the number in accumulator. Another number can be in register. It can be in memory. Then add the numbers and at location 4002, you have to display the result. Just remember, result will be in accumulator, which you have to display at location 4002. So LXI H 4000, load 16-bit immediate value into HL pair. So HL is being pointed by 4000. Then move A comma M. So copy the contents from memory to accumulator. So the first data which is present at location 4000, it is being transferred to the accumulator. Let's say 17 is being moved to the accumulator. Then INXH, increment HL pair by 1. So HL was having 4000, I increment it by 1, it becomes 4001. Then I write add M. Add M says that you have to add the contents of accumulator with the contents of memory as pointed by HL pair and store the result back in accumulator. So accumulator was having 17, memory is pointing to this location 4001. I assume it to be 03. So you will add 03 with the contents of accumulator and the result, that is 1A, it will be stored back in accumulator. So now this result you have to display at location 4002. So again we write INXH, increment HL pair again by 1. And now you can transfer the contents of accumulator to memory location. So this result will be displayed. Last halt, terminate. Next is you have to subtract the contents of location 4001 from 2000, and you have to place the result in another location. So same way, like in the last program I have added the numbers. In this program I have to subtract the numbers. So the same concept will be used. First load the numbers in accumulator, one number in accumulator, other number can be in accumulator or memory, then just subtract the numbers. So we'll see the program. So see, LXI H 4000. So first HL pair is being pointed at location 4000. The number which is being present here, for example 45, it is being moved to the accumulator. It is in accumulator. INXH, it becomes 4001. Subtract M. Now M is pointing to HL pair, HL is having 4001. So whatever data is here, let's say 23. So subtract M says that you will subtract the contents of memory from accumulator and display the result back in accumulator. So you have got the answer in accumulator. So you have to just increment the memory pointer and display your result at the next location. Last instruction should be terminate, halt. So this was about the simple programs that I have to add the numbers, I have to exchange the numbers, I have to load a number. Now we'll discuss about some concepts like if I have to pack two unpacked BCD numbers, they are stored at two locations. I have to store the result in another. Now what this unpacking and packing means? So this question says that I have two locations, 4200H and 4201H. At these two locations, I have got two unpacked BCD numbers where and at 4300 I have to display the result. I have to assume that the least significant byte is present at this location. So I have to pack the numbers. These two are my BCD numbers, they are unpacked BCD numbers. When I have to pack the numbers, that says that I have to combine these numbers. So my result I should get as 47, 7 being the least significant byte. So how can I do it? That means first thing I should do is I have to make this, I am having 4, so I should make it as 40. Then I can add it with the other number, so it will become as 47. So we'll see how can we write this. First is LDA 4201. So you have loaded the number from location 4201 into accumulator. So in accumulator you are having 04. Now I have written 4 times the rotate instruction. Rotate left through carry. So when you will rotate the instruction, when you will have the 4 times rotate instruction used to shift data bit by one position. So after 4 rotations, my lower nibble and upper nibbles, they will be swapped. So instead of having 04, I will be having 40. Next is I says ANIF0. It may be due to carry or due to any noise. The data may get vary. So because I am interested only in this upper part, F part. So I says just mask this the lower 8 bits. The lower 4 bits. So we said that you have to perform the AND operation with F0. So the number where I am interested, I have placed F there. So I will get answer as 40H. And just I have keep it in register C. Then again loaded the data from 4200H. So 4200 is having the data from 07. Then add the numbers. C is having the 40 which you have got after rotation and after masking bits, and accumulator is already having the LSB bit. So 40 plus 7 you got the 47. You have to display this at another location 4300H. Last, halt, terminate the program. Now 2-digit BCD number is stored at location 4200H. You have to unpack the numbers, you have to display them at 2 locations, and such that the 4300H have the lower BCD digit. So this time at location 4200, I have got the number as 47, and at location 4300 and 4301, I have to display the unpacked digits. So 4300 should be having the lower byte. So 07 and 04. This is my end output which I expect as outcome of this program. So how can I do? I have got a number 47. So first I can say that from the number 47, if I perform AND operation, because at one time I am interested only in this place. If I perform the AND operation, if I perform the masking, I'll get it as 40. Rotate it 4 times, you will get it as 04. Same way, again take this 47 and this time perform the AND operation with 0f, you will get it as 07. Just display it. So, we will get both the numbers. So, LDA 4200H, load accumulator with the contents of 4200. So, you have got 47 in accumulator. ANI F0. So, mask the lower nibble. So, you have masked, then rotate it 4 times to get it as 04 and just display it at location 4301. Then again load the number from location 4200. So, you have again got 47 in accumulator. This time just mask the upper nibble and display the result at location, another location. Last halt, terminate the program. Next is we have to calculate the sum of a series of numbers. So, I have got a like the last example we have discussed about the addition of two numbers, and now I say that I have got a series of numbers, it's an array, and the length of that array is stored in the first location, and then from the next location the numbers are being started. And first part says that we have to assume the number to be a 8-bit number. Next part says we have to assume the number to sum to be a 16-bit number. So, for example, at location 2200H, I have 03. So, it says that from next 3 consecutive locations, you are having the input which you need to add. And you can just display the result at location 2300H. So, I assume my 3 input, I have to assume the sum to be a 8-bit number. So, I take it as 80. 10, 20. First is LDA 2200H, load the data from location 2200H into accumulator. So, that it is the accumulator you are having the first input, which is the length of string. So, I have stored it in register C, it represents the length of array. Then subtract A. I have to first clear the accumulator, so that to balance out the number of iterations, because from 0 to 03 if I will go, then it becomes 04. So, I will first balance the number of iterations. So, either you can decrement the counter by 1 or you can just simply clear your accumulator. You can clear your accumulator using subtract A, or you can use XOR A. In this way also you can clear the contents of accumulator. Then let us say H. So, HL is being pointed at my first location 2201. Then add M. Now see, it will add the contents of accumulator plus memory. Accumulator is having 00, memory is having your first data. You will add the numbers and the result will be in accumulator. So, it will be just replaced in accumulator. First you have performed the addition, increment HL pair by 1. So, HL will be incremented, you will reach to 2202. Now, you perform one time addition. So, you must decrement the counter so that you can count how many times you have performed the addition. So, decrement your counter by 1 and check whether it has become equal to 0. So, 0 flag will be set if the result of any arithmetic and logic operation is 0, but my result is not 0. So, 0 flag is not set. So, I will just go back, I will again perform the addition M. So, now this time accumulator is having 80 and memory is pointing to 20, you will get the result as 90. Again increment H, you got to this location 2203, just decrement your counter by 1, it becomes 01. Still it is not 0, we will again go back. We again go back, we again added the numbers. So, I am having an accumulator 90, I added it with 20, it becomes B0. Incremented, so we got to the next location 2204. We decremented the counter by 1, it becomes 00. C, now this time the C is having value 0. So, the 0 flag will be set to 1. So, 0 flag is set to 1. So, jump if not 0, this condition. Jump if not 0, this is 0. So, the condition becomes false. So, we cannot jump. Instead, we will go to the next instruction, which is INXH. Again, increment the number, HL pair by 1 and just display your result. So, I have just displayed the result at next location, or you can directly write after this J and Z, instead of these two instructions, you can write STA 2300H to display the sum at this particular address. Last instruction, halt, terminate the program. Now, my second part says that I have to assume the sum to be a 16-bit number. So, that means I have to incorporate the carry part also. So how can we write? The complete program will be same as we have discussed in the previous part. What changes I have to make? I have to assume I have got 32200. I have the length of array as 03, 2201, 2202, 2203. 3 inputs I am having. Maybe FF, FF, and let's say 10. So first you have loaded the number, you have stored it in register C, so you are having the counter value in register C. Then you have cleared the accumulator C. Now to store the carry part, you need to have a empty register. So just take a empty register. So for that purpose, I have taken register B. So B is being used to store the carry part. Then add M. So again you will add the first number. So A plus M you will perform. A is having 00, memory is having MM. First time you have performed the addition, you will got the result back in accumulator as FF. Now I will check the carry. Jump if no carry. Is there any carry generated? No. If there is no carry, I have to move to this label X. I will increment the location, go to this location, decrement my counter by 1. Is this become 0? No. Again repeat. Again perform the addition. Again you will add FF plus FF. You will got answer as FE in accumulator. Now, but this time when you have performed the addition, your carry flag will be set to 1 because you are adding the two maximum 8-bit numbers. So again we check the condition, jump if no carry, but this time carry is 1. So if carry is 1, you have to increment this register B by 1. So it was 0, it becomes 01. Again increment your HL pointer by 1, decrement your counter, it becomes 0, no, again repeat the process. So in this way, you can just, with the help of a separate register, you can store your carry bits also. And at the end, you have to display the accumulator result at one location and the result is stored in register B, which is my upper 8 bits at other location. Now you have to multiply two 8-bit numbers stored in location 2200 and 2201 and store the result. That means we assumed my answer to be a 16-bit number. See, 8085 doesn't support multiplication and division instructions. So if I want to multiply the numbers, that means I have to perform the repeated addition concept. So we say, let's say I want to perform 5 cross 4. That means I have to add 5 4 times. So what we'll do, we'll just perform this 5 4 times. We'll take a counter. So we'll using the concept of a 16-bit register pair. I'll take it in register E and clear the upper part of register D so that I can make it a complete register pair DE. I'll use DAD instruction here. Just see LDA 2200H. So the first data 05 being moved to register E and you have cleared the D part. So it becomes a 16-bit number 0005. And this data I am being treating it as a counter. Now HL pair is being cleared to 0 to perform DAD. DAD instruction used to perform 16-bit addition. It adds the contents of DE pair with the contents of HL pair and store the result in HL pair. Now see, HL is already clear. So you are having 00 in HL. DE is having the first input 0005. Just add the numbers and you will got the result in HL pair. So I don't need to think about the carry because already I performed the 16-bit addition. Just decrement your counter by 1. If it has not become equal to 0, again perform this addition. So this time 5 plus 5, because HL is being updated, so you will get your answer as A. Again decrement your counter by 1. So it was 3 previously, now it becomes 2. It is still not 0. So again just go back and increment, just add the numbers. So in this way, at the end of 4 iterations, you will be having your answer in HL pair. Just display it. Now I have another new instruction, SHLD. So it says store the contents of HL pair at this address. So the contents of register L, they will be transferred to this address 2300H, and the contents of register H, that is the upper 8-bit, it will be transferred to the next address, that is 2301. So 2300 and 2301, it will be having my result. So the contents of L register will be here and the contents of register H will be displayed at this particular location. So this was all about the programming concept used in 8885. If you have got any doubt, then you can contact me. Thank you.